Okay. Confirm? Confirm? Okay, I'm going to cancel this. Remember, we're ignoring the original. We're going to the canceled version. Okay, we have to find the y coordinate of the hole. How? I just see a lot of erasing, so I'm just going to stop. Tell me what the erasing's about. Forgot to cancel. Anybody else? Jenna, there was a lot of erasing there. What? What did you miss or what? Back to the original? And what happens is when you put this into here, you're going to get 0 on the bottom. Right? That's why we have to go to this one. How do we find the y value of the hole? Substitute into here. Okay, what's the common denominator? And this always makes me giggle a little bit because if I were to put sines and coses, you can do this now, but suddenly when it's numbers, there's like panic across your faces. But sine and cos is all good. So if this becomes 2, what's the top going to become here? Okay, now what? Okay, so what are the coordinates of the hole? You can't do 1 as a decimal, 1 as a fraction. If you're going to decimal it, you got to decimal it the whole way. Step 2. Okay, so analyze the degree. Remember, we're going back to this guy here. Degree on the top. So there is an x here. We don't see it. That's an imaginary x, although it just looks like measles. But what's the exponent on the x when we don't see it? Can't be an x to the 1 because we would see it. It has to be an x to the 0. So there's an imaginary x to the 0 when you just have a number. So what's that degree? 0. What's the degree on the bottom? 1. So this is degree over d plus 1. Conclusion. Questions so far? What shape is this going to be? This tells you the shape right here. 1 vertical asymptote means it is volcano. Okay, step 3, intercepts. Okay, how do I get rid of a division by x plus 3? Multiply. What's 0 times x plus 3? 0 equals 1. What does that mean? Could 0 ever equal 1? So what does that tell you about the x-intercepts? There aren't any. Which, considering this is your horizontal asymptote, that has to make sense. Because if there's a horizontal asymptote there, can the graph pass through there? No, so it actually makes sense there's no x-intercepts. What about the y-intercepts? Offer of a third. Questions so far? Okay, what would you like to draw first? Okay, vertical asymptote. Which way does a vertical asymptote go? Horizontal. What would you like to draw next? The hole. Okay, so negative 1.5, 0.6, and I'm going to draw a really big hole just so you can see what I'm doing. So I took up the whole box just to make it really obvious for you. What would you like to draw next? The y-intercept's all we have, so it's at a third. What's the shape? Let's put it back in our heads. It's got to be volcano, so this side we can do because we know it's got to approach the asymptote, go through the x-intercept, skip the hole, and then approach the vertical asymptote. What we don't know yet is where's the other piece. So we have three possibilities. It could be on the left, it could be diagonal, or it could be on the bottom. I know it's not on the bottom. Who can tell me why I know that? So how do I know it's not down here? Because we only have one y-intercept, so to go in this section it would have to cross again. So now I'm down to these two. How can I figure out if it's on the top or it's on the bottom? Test point, okay, so something in this region. What would you like to pick? Minus 4. Okay, what do we do with that value? And where are we putting it back into? We got a lot of stuff going on here. Okay, so back to the original, or sorry, the factored one. Offer of minus 1. Okay, so that gives us minus 4 minus 1. So what does that tell us about the second part of our volcano? It's on the bottom. So there's a combination volcano and graph with hole.